Hello fellow physics students, I'm Matt Medea and I'm going to talk to you today about physics experiments. Now, one important thing with physics experiments is the scientific method. Now, you may not have a teacher specifically say, yeah, follow this and this and this and this, but there's a general outline to the scientific method. You have an idea, you test it, you find your conclusion on it. Now, I'll give you a quick example here. Let's test the gravitational constant of Pittsburgh, Pennsylvania. So I asked the question, what is the gravitational constant? To which I would make my hypothesis that I believe that it is about 9.8, just like most of the other places on the surface of the Earth. However, I'm going to test it. But before I do that, I do a little bit of research to see what other physicists have done before me to see what I should try and do. So I would look at Cavendish, Newton, other famous, Einstein, and look at some of their work to see what I could bring in. Next, I would test so I would come up with a procedure. One thing I could do is to use this piece of plastic, drop it, take a video of it, and find how much it accelerates. However, that's a terrible idea, because I'm not accounting for other variables. This piece of plastic has a huge amount of surface area for a very little amount of volume. Now, that surface area will increase the drag as it falls down, which just messes up the forces. It'll decrease the show of gravity. Now, I could do something a little more reliable, such as a pen, and drop that point down. That'd decrease surface area. But if I want to do this perfectly, I do it in a vacuum where there's no drag whatsoever. But budgets don't often allow for that, and you gotta work with what you have. And this should be a reliable way to test it. So what I would do is, first I would set up a scale to perform my experiment, which could be something as simple and common as a physics textbook, which you know the lengths of, or even a ruler. Now, you could use these to show how much it falls as a scale, as I said. Now, what I would do is I would take a video of this, which I already am, drop this, and then I go into a program called Tracker, or there are several others like Logger Pro, or all these different types. But what it does is it allows you to pinpoint information. However, this all falls under the general category of analyzing data. Once you've analyzed your data, you find your results and see if maybe I was right. Now, I'm pretty sure that I was in this one. Tried to increase my reliability. I apologize. But say I don't. I would go back, test it again, redot it, try it again. If I do it several times and it doesn't work, I'm probably doing something wrong, or I should have another person try and analyze my results. Say I get it right, though. I would also want to collaborate with other scientists to determine whether or not they get the same findings. It's a collaborative process, starting from the individual and going into a much larger scientific community. But there is a general process that you should follow. Scientific method.